Greetings, welcome to the InvMark for Autodesk Inventor launch video, part 2 for nerds, for enthusiasts, for people who want to know more about what I've been up to, what this is all about, who are interested in the behind the scenes stuff and some extra gems and features and things that make this just so awesome. This is unapologetically long, this video, but if you don't want to indulge my waffling, along the timeline you will see it is broken up into chapters. I've broken this up into chunks, so if you don't want to listen to me waffling about any one particular thing, you can jump ahead and flick between different things. It's all broken up into named chapters. Okay, InvMark is a complete benchmark solution for Autodesk Inventor. It runs a series of around a dozen or so tests on your workstation or laptop. It will grade how well your workstation performed those tests on Autodesk Inventor, and then it will give you a score. In fact, it gives you about a dozen scores. And then you've got the option, if you want to know what those scores mean, you can upload your scores to the InvMark Leaderboard, where you can compare those scores against other people in the Autodesk community. Alternatively, you can just go to the leaderboard and check out what's good to see what laptops and workstations are performing best today on Autodesk Inventor. That's what it's all about. Designed by me, developed by Karak Group, website hosted by Karak Group. Autodesk Platinum Partner based in the Netherlands, but also operating across Europe and in the United Kingdom. Okay, if you want to get your hands on InvMark, this is how you do it. This is how you download it. So you want to head on over to invmark.karak.com. Go to the About InvMark link at the top, and then just select Download the add-in. That will immediately begin downloading it. Now, obviously, I've already downloaded it. It's fair to say I've got it already. I've only been working on it for 14 months. But whilst it's downloading, I strongly suggest and highly recommend you check out this page. We need to update it at this present time, and probably on launch, it's not finished. But check it out. Also check out the other links at the top, because we're going to have some system requirements that you might need to be aware of. I'll say what they are here. System requirements. Inventor 2021 and Inventor 2022. On day of launch. Moving forward, all future versions of Inventor. We're not supporting previous versions older than Inventor 2021 because of dataset reasons. In addition to that, the hardware requirements for InvMark is just whatever Autodesk's requirements are for Inventor. If you can install Autodesk Inventor and run Inventor, you can install and run InvMark. There are some caveats though. Did I cancel that download? Why is my little green bar going on? Never mind. The caveats for running InvMark, there are a couple of things which we've intentionally explicitly blocked. The first thing is running Autodesk Inventor with elevated permissions. If you right-click on the shortcut and run as administrator, you will not be able to run InvMark. That has been blocked for reasons. One of our tests had issues whilst running with elevated permissions. No other reason than that. It's not because it runs the tests faster. It doesn't. Inventor does not run faster with administrative permissions. It just caused an issue with one of our tests, so we just had to stop it from happening. We didn't have time to go into it, and it wasn't a priority. Second block that we've put in, resolutions, monitor resolutions. If your monitor is capable of running at 1920 by 1080, but you set your display lower than that, we block the test from running. This is to stop people from trying to set their resolution to a postage stamp size in order to make the tests run faster, because less pixels on screen means that a lot of the tests just passively run faster. The 1080p is the baseline. However, if you're running a monitor that's not capable of 1080 and its max resolution is 1280 by 720, for example, then that's okay. If that's your max resolution, that's okay. It's designed in that if you've set it lower than a capable resolution of 1080, then we block that from running. There's also a couple of blocks in place with regards to some registry keys, which historically I've found to be a way of increasing graphics performance in Autodesk Inventor. They use multi-threading key, for example, in the graphics area of Inventor's registry key positioning. If you change that, I block InvMark from running. I think Autodesk they've stopped delivering that key in 2022, but in Inventor 2021, if you do change that key, InvMark will be blocked from running. You have to change that key back to what it was. Okay, to install InvMark, once you have downloaded it, just give it a double click. And then the installer comes up. This will probably tell me I've already got it installed. Yeah, it has, yeah. And then just click next, next, next. and then that will begin installing InvMark. That's all there is to it. Next. Now, there's a couple of installer issues that I'm aware of that if you come across them, these could be the issues. The first one is, and it's very unlikely that you've got this, but it's one that I'm aware of. We install a component called the Microsoft Edge Web View 2 runtime. This is a little applet that runs inside our add-in, which allows you to look at the InvMark leaderboard from within Autodesk Inventor. If you've already got this runtime installed, then our installer fails at the end. It doesn't tell you why, it just fails. So if you get a message at the end saying that this installer cannot complete and it has to roll back, check for the presence of this Web View 2 runtime, uninstall it, and then run InvMark again, and you should hopefully be good. The second issue that I'm aware of, which I think we fixed, but I'm not 100% sure, is at the end of our installer, we run a batch file out of this directory, C program files x86 InvMark. We create that folder. We put this batch file in here, and then we run this batch file. This batch file is basically just installing a trusted publisher certificate. It's a digital certificate which signs our add-in for Autodesk Inventor. It means the add-in doesn't get blocked. Some cloud security systems have blocked that batch file from being running this. They saw it as a risk running a batch file, which is fair enough, right? I get that. But at the moment, that's the way we're doing it. If you've checked that you don't have the Web View 2 runtime and you're still getting an installer block, then all I can suggest, I can't ask you to, but just suggest is ask your IT to put an exclusion or an exception in for this folder here and allow scripts to be run within this folder. Obviously, it's perfectly safe. If you want to show your IT what the content of the script is, that's it. It's running it. All it's doing is just adding a trusted publisher certificate. And that's it. Okay, those are the two installation issues that I'm aware of. So you can run Autodesk Inventor 2021 or 2022. InvMark runs as an add-in. You don't have to. There's no separate button on the desktop. There's no separate button in your Windows Start menu. Once you load up Autodesk Inventor, you'll see the InvMark ribbon bar panel at the top, and then you can select the InvMark icon. That'll load up our user interface. Okay, what I'll do is go through the InvMark user interface and I'll show you what all the buttons do and then give you the rundown on what you're actually looking at. When you first click the InvMark button, we're gathering a couple of system stats just to let you know, okay, we've identified and established what your system is. If any of these system properties are blank, get in touch with us because there'll be problems uploading to the leaderboard if any of these are blank. And then we verify the dataset integrity, which is us checking our files on disk to make sure they haven't been, make sure they're installed correctly, but also making sure that nobody's tried to tamper with the files. Okay, it's a benchmark test. If someone's tried to edit, replace any of the files, we check for that, and it's an anti-cheat mechanism. So that's what we're doing there. And then once that's done, you should be able to then freely move around the InvMark palette at your leisure. The InvMark user interface itself, we've had lots and lots and lots of issues with this on display scaled laptops. We've fixed a lot of them, but I've no doubt there'll be some that we've missed. So if you're running, I don't know, 1440p at sort of 300% scaling, I don't know, right? We've tried to make it look okay on most scaled displays, but it's not going to be perfect on every one. But at 100% display scaling, it looks great, right? But 4K 300%, the add-in interface is big, and we've tried to make it look workable. Okay, on the left-hand side, these are your system stats. Just checking that everything's okay, right? The graphics card here says NA. That's because I'm looking at this through remote desktop. There's a couple of system stats that we can't quite grab when you're using InvMark through remote desktop. But InvMark is fully supported through remote desktop. You can run the tests through remote desktop. And I can verify and confirm that running InvMark through remote desktop doesn't cause a performance drop. There's no graphical downsides, right? You'll get the same performance level running InvMark through remote desktop as you would do if you were physically sat at the workstation running it, which is a good thing, right? Again, a lot of work was put in to make sure that was the case, and that happens. It's just a couple of the system stats we can't quite read, and that would be I think that stat there is the VRAM. Run individual tests offline. This is the first configurable button that you have to play with. So if you give this one a click, right, the little square, this will take you into a separate environment where you can, if you want, run our individual tests in isolation. So these are 9 ticky boxes, which will allow you to run, for example, just the drawing test, just the FEA test, or in conjunction with each other, numerous tests at once. And it'll give you an individual score per test. What you can't do is you can't tick all of the boxes and then upload those scores to the leaderboard. You can only upload to our leaderboard after you've ran the full InvMark suite using that button there. Anything that you run from here is purely offline. It's for your testing. The reasons why you would do this, I mean, I've used these extensively during the development. It's for example, when I was testing the FEA test, when we had issues with the FEA test, which I'll talk about a bit later, I don't want to run the entire InvMark suite just to witness what happens during the FEA test, so I can run that in isolation and see what happens. Also, if you make any system changes like overclocking memory, overclocking CPU, if you replace your cooling system, if you upgrade your graphics card, if you do anything to your PC and you just want to quickly witness any potential change to how that affects the performance of your workstation, you can just run a quick baseline test, say the modeling test, for example, or the graphics test, and then make that system change, run just the graphics test again, and then you can witness those changes without waiting for the full suite of tests to finish. So it's good for that. So those are the individual tests. And like I said, nothing done there can be uploaded to the leaderboard. It's all offline. And then you just click Start Test. And then that will send them off on their way. Right. This second one here is Capture PC Performance Data. I am so excited for this, mate. This is awesome. I'm going to cover this in much more detail at the end, like how it's done. We have a sensor logging system running whilst the benchmark is in progress. No personal information is being captured. Absolutely, you have my word on that. We are not capturing any personal identifiable information. All we are doing is we are taking all of the sensors on your motherboard, your CPU, your RAM, your graphics card, the VRMs, any available sensors in your PC, and we're logging every second temperatures, frequencies, fan speeds, how much RAM you've got available, how much RAM you're using, how much RAM you've got left. Just everything available. We're logging it every second whilst our test is running. And we're logging it to a CSV file. You can look at that data if you want to. I'll show you how to do that at the end. And then you can convert that into a graph and witness how your PC was performing over the duration of the benchmark test. It doesn't cause a performance hit either. It's all we're doing is logging to a CSV file. It's such a light task for modern computers to do that it does not cause a performance bottleneck. If you don't believe me, you can test it yourself. You can untick this, run InvMark, tick this, run InvMark, compare the scores, right? I've done this plenty of times, right? Of course I have. And it didn't make any difference. It's so light, right? Especially on multi-core, multi-threaded systems, it doesn't cause a performance hit. But you do have the option of turning it off if you don't want to have that running in the background. Okay, then you've got a number of runs. You can increase this, and I don't think I asked for a limit on this. This just carries on going up and up and up and up and up, right? Bear in mind, though, that every run InvMark, so every full test suite, at minimum, takes around 7 to 8 minutes at its quickest. That's the full test duration, around 7 to 8 minutes. The nature of a benchmark test is it will take longer if you've got a slower computer. Of course it is, right? So the longer, or the more test runs you put in there, the longer that's going to take. But the way this works, and why I've done this, is if you do 5 runs, what we do is we run InvMark 5 times, and then we take the fastest modeling time, we take the fastest drawing time out of all 5 runs, and then we create a super score at the end of them. So we're not taking averages or anything like that. So if the graphics test was fastest in run 3, we extract that and we use that for your upload. If the ray tracing score was fastest in run 1, we take that and we use that for the super score. So we pull out the fastest times from all 5 runs, and then we use those to create this big, huge super score at the end of it. So in theory, the more runs you do, the higher chance you've got of getting a better score, because by nature, Inventor is a multi-threaded application, single-threaded application. And it's just how it is, right? You can catch your PC doing something on a bad day, things happen in the background, it slows it down. We've done everything in our power to make this test as consistent as possible, and it is super, super consistent. Like if you look at our leaderboard, for example, The two systems in second and third place, these are identical laptops, two completely different computers, right? These are two separate pieces of hardware, but you can see one is 40,010 points. This one's 39,900. There is 30 points separating the two systems. That's outstanding consistency. The hardware's the same, so you would expect it to be that close. But that's how consistent this test is. And we've put so much work into making it that consistent. But we can't control things firing up in the background. Antivirus software. I made a video in the past showing how much of an impact antivirus software actually has on CAD software. It can slow things down by up to 20%. And so can other things that you've got going on. So we've done everything we can. When there's nothing else affecting the system, this test, again, you have my word, is as consistent between runs and between systems as any test could possibly be. So that's that. Run InvMark will run the tests, right? Once you click Run InvMark, we do one final check to make sure no one's tinkered with anything since we last verified the data set integrity. And then we give a quick warning to say, by the way, this might take a while. Then you click OK, and it'll start the tests. At the bottom, we've got the leaderboard button. This will open up this web view component that I spoke about earlier on in the installation system requirements part. Open up a window into our leaderboard, and then you can just, it's the same as going to, opening up Chrome and looking at the leaderboard, but it allows you to sort of localize everything within the add-in, so you can just sort of, you don't have to go somewhere else. You can do it all within the add-in, right? It's just you can log in here as well. And then once the tests run, you can actually upload your scores and see that here. It's a nice it's a localized container to do it all within. So it's a nice touch. So that's the interface. On the right-hand side, here's your three scores, which are blank at the moment, but once they're finished, they'll be populated with a single-threaded score, a multi-threaded score, and then a full InvMark score. I'll explain what those are later on. So then you click Run InvMark, click OK, and the tests will begin. Okay, I'm glad I broke this into chapters because we're 20 minutes in nearly, and we're just starting the tests. I have to go through everything. Right, once you've started InvMark, the first test that happens is the modeling test. Right, what I'm going to do here, again, you can skip past all this if you're not interested in hearing me talk about the tests, but I am going to explain my thought process behind a lot of these tests, some things I had to give some consideration to, and, things that you just might be interested. If you're not interested in, you don't have to watch this, right? It's one of those things. So the first test that we saw is the modeling test. And I feel like I need to make a point of saying that I'm not interested in extrusions, sketch lines, and, creating fillets and timing how long a workstation takes to tap holes and stuff like that. Today's hardware is so powerful. Writing code to draw sketch lines and create fillets and extrusions and revolves is nothing, right? It can steamroll. Today's hardware can steamroll through an execution pattern or a list of so many of those simple sketch features and simple part modeling features. It's not even a challenge. So what I've done is I've teed up a solid sweep. I time how long it takes your workstation to create this cylindrical extrusion, tap a few holes, do a pattern, create a little cube, right? Some basic part modeling features are in there, right? But that's not what my part modeling test is about. It's about this. We create a center line for a solid sweep, and then we execute a huge solid sweep cut execution. And this is so computationally expensive that it really, really challenges the workstation. And this is what our part modeling test is all about. There it is. It's just finished there. So the solid sweep execution is multi-threaded, meaning that it's not 100% multi-threaded. I think it's Amdahl's law kind of kicks in. It's part multi-threaded, single-threaded operations are mixed in with it. So there's a bit of sort of diminishing returns on it. But this operation will go towards your multi-threaded score at the end of InvMark, because the more cores you have on your workstation, the faster that will complete, but it's sort of muddied by single-threaded clock speed as well. So it's not 100%, but it is a multi-threaded operation, so it will go towards your multi-threaded score. After that solid sweep's done, we float a bit of text off of the cylindrical surface. We emboss that. We measure how well your workstation performs that, and then we pattern that emboss around the cylindrical face. And then again, these are really hard-hitting, computationally expensive operations, which even on really good workstations take a while to do, So I'm quite pleased with those, right? The next test after the modeling test is done is the FEA test. Right, this one was, this consumed months of our development time because FEA does not have an API in Autodesk Inventor. I'll not go into it, but I just want to say a huge thanks to my developer for putting up with me throughout this. It's my persistence and just reluctance to accept the way it was behaving in the past, the inconsistency with how this was. He must have been regretting his life choices, but he's done an absolute stellar job, and we've arrived at a point where our FEA test is super, super robust. And the reason why it's so challenging is because you can't execute the start of the simulation through the API. There's no call to start it through code. We went round the door so many times, but we've arrived in a really good place. And at this point, it's as good as indestructible. So the FEA test begins. On the left-hand side in the browser structure, you're going to see that the mesh node has a flash of lightning next to it. That's because I've intentionally left the mesh out of date. So the first thing that the test does is it updates the mesh, which is, again, computationally expensive. It's a bit of work that it's got to do. After it's finished computing the mesh, then it starts on solving the simulation immediately afterwards. After it's finished solving the simulation, that's when it'll present the results. The wheel will turn blue. That's the test over. And then we measure how well your workstation does with that test. Once that's done, we move on into the next test, which is the parametric part study. That is this thing here. So this is a parametric table FEA static analysis. The brackets on either end of that rod, you'll see them changing in size. So a parametric study is where you create a table in Autodesk Inventor and you program in however many sizes you want that bracket to potentially be. So you create a range of values from, say, 10 to 100 mil, and then Inventor will perform a simulation with that bracket at each of those 10 sizes. It then computes them and then does essentially 10 simulations and then hands you 10 sets of results at the end. So it's quite an underrated and underused area of Inventor, I feel. But, we're running 10 sets of FEA here, 10 simulation runs. So yeah, I felt that was a good candidate to be in a benchmark test. And then once that's over, the results, there you go, done. And then we move on to the next one, which I believe is our drawing test. So for our drawing test, okay, right, yeah, this one wasn't. The drawing test is something that we were changing 3 or 4 days before we actually released InvMark. The reason for this is we were experiencing asynchronous execution issues with the drawing test. I'll not go into it. It's boring stuff, but we were finding that the way Inventor was placing the views was not consistent depending on the state of the user's workstation, and kind of trying to measure how and when things were happening was an issue. I'll just leave it at that. So what I've done instead, to make this a lot easier, you may have noticed that just before the drawing template opened, a factory opened in the background, a factory assembly. So the reason for this is kind of related to what I've just said, but not related. When you place a view onto a drawing in Inventor, Inventor can't create that view, and it can't even place the view unless the data it's creating the view of is open in RAM. Right? Inventor needs to reference that data in order to place a view of it. So when we're doing a drawing test and placing that first view, the first 30 seconds or so of that drawing test was Inventor loading that assembly into RAM. To me, that's not a drawing test. That's loading data. It's not a drawing test. So what I've done is I open the assembly first in the background, just let that happen passively in the background. Then once that's finished opening, we start the drawing template, then we place the drawing view, and that's when we start the timer, is when we start that drawing template. So all the loading of the data has already happened. So what we're actually timing is true, raw drawing view placement and background view computation. And that's where the drawing test is really at its kind of peak. And what we're really timing here and measuring is these green chevrons. Inventor is now calculating all the views, what lines should be visible, what data should be on show, and then it's finished when the little green arrows disappear, and that's the drawing finished. Okay, the next test is dynamic simulation. Kinematic simulation, a hugely underrated, underused area of Inventor for many reasons. It's an enigma, this environment, even to Autodesk, I think. It hasn't been given many updates. I'm not sure if they even can. I don't know, but it's a fascinating environment. But you do need to really know your stuff to kind of get the most out of this. All we're doing here is we're opening up this assembly. I've created around, it's so long ago since I made this, but I think between 12 and 18 data traces on various points of the mechanism. Then we play the simulation player and we're logging those data traces as the mechanism's moving. So it's measuring on each data point velocity, acceleration, the XYZ positions of those data points. And that's what this graph is. Every one of our data traces, the little squiggly line that's going up and down, that's its, I think that's its velocity or torque or acceleration. I don't know. I haven't investigated it. I just wanted something to measure, to log, play the simulation, and let's see how well the workstations handle it. So yeah, that's the simulation. We're not measuring how a workstation creates the simulation from scratch. That would take forever. So we're giving your workstations a pre-created simulation environment, and we're playing that simulation with the data logging happening in the background. And then that's it. It plays the mechanism, and then it moves on to the next test, which is no, it's not the graphics test. This is the pattern test. So we're opening up the factory assembly again. We use this factory assembly several times across the duration of the benchmark test. This is public data set. It does have Fanuc robots in here, but they have been provided to Autodesk, and Autodesk provided this data set to me. So thank you to Autodesk for giving me this data set. Everything here is in the public domain and free to use. So we open up this assembly, and then once the assembly's opened, we then create 5 pattern instance of this large assembly. So say a large assembly's got 932 unique parts in here, and then once it's finished patterning, that's quite a heavy test, right? That's a pattern of 1,000. It's 932 parts, but it's as good as, damn it, 1,000 parts. I had to reduce the part count in the assembly because I had to strip out a few bits and pieces because of Inventor Professional parts being in there, like cable and harness modules and wiring pieces. It was throwing errors for people who didn't have those modules loaded and whatnot, so I had to get rid of them. But it doesn't matter. But either way, a 5 occurrence pattern of a 1,000 part assembly is a very, very, very stressful operation on Inventor and your hardware. It's a good test to have. So that's a 5 pattern assembly test. It does that, then it moves on. And then we're into the assembly build test. Very similar start to the last one. It starts a brand new assembly, so a blank template. Then it places the factory in this time. So we're not opening the factory, really, we're placing the factory as a sub-assembly. We do that 3 times. So we place 1 instance, 2 instances, 3 instances of the 1,000 part assembly. Once they finish placing, we then constrain them together using mate and flush constraints. So you'll see them kind of joining together. You don't witness it happening kind of in real time. Something to do with the viewport not refreshing in real time. You can kind of see it happening, but yeah, it doesn't sort of smoothly move around like things sort of popping together like it would do if you were placing it yourself. But in the code, we are placing 1 instance, 2 instance, 3 instance, and then we're placing 3 constraints between each of these, and then measuring how well your workstation does that. So this is a large assembly build test, it's one of those things that people complain about with Inventor, right? Assembly performance, putting constraints together with large assembly. So there's a test for that, large assembly build. Okay, and then we've got the graphics test, right? The graphics test is broken into different categories. It's got sub-graphics tests and then separate kind of entities within itself. So it starts off with an assembly graphics test using this jet engine assembly. And the first view is just sort of shaded with edges, right? It's just normal kind of, as you're modeling, normal Inventor mode kind of graphics. This test that you're looking at was recorded in OBS through remote desktop, so it is kind of really jerky and sort of, yeah, it's not the best. Then it moves on to, it's the same assembly, but then it measures shaded with hidden edges on. Then we move on to wireframe, which again, it's remote desktop, so things are sort of laggy. Visually laggy, not actually laggy. And then we move on to, after it's done the wireframe version of the graphics test, we move on to full pretty mode, which is reflections on, all shadows, ambient shadows, object shadows, ground shadows, with realistic textures, IBL, the image-based lighting, all that enabled. And then after it's done that with the jet engine, so that I think there's 4 different graphic styles for that assembly test, it then does the exact same thing with a part. In this part, it looks like an assembly, but this is a part, right? Again, modern hardware is so fast. If you just model a square, right, a simple part, it spins so fast. It's almost immeasurable. Doing a figure of 8 orbit on one of these wheels happens so fast. You're talking tenths of a second. It's crazy how fast it orbits. So it's the same for graphics tests, right? There's the realistic pretty mode. That's assembly. That's part mode. Then we move on to a different set of graphics tests that I'm pretty sure you weren't expecting. We open up the assembly again of the factory. We perform a baseline orbit test on the assembly. So we take the factory and we do a figure of 8 orbit of just the factory on its own. And this is in full mode, right? Not express mode. So this is with all parts loaded. Then what we do after that orbit test's finished is we select a subassembly of robots. So we're now doing an orbit whilst parts are selected in the assembly. The reason we do that is because it's one of those things. It's a long-standing issue in any 3D CAD program as well. So you've got parts selected, navigation becomes difficult. So we select the subcomponents and then we do an orbit whilst they're selected. Once that's done, and we've measured how well that happens, we then edit the parts. We then do an in-place edit on the subassembly of robots, and then we do the same graphics test again. We measure how well your workstation performs that orbit. And that's your graphics test. So we've got multiple points of entry for that graphics test. Assembly with 4 different visual styles, part mode with 4 different visual styles, and then we've got a regular large assembly graphics test, 1,000-part assembly graphics test, then a 1,000-part graphics test with parts selected, then a 1,000 parts graphics test with an in-place edit mode enabled. Once that's done, we then move on to the ray tracing test. The ray tracing test was going to be an in-canvas ray trace. And what I mean by that is I was just going to open up a model, just go to the View tab, click ray tracing, and then measure how the performance was there. Yeah, that was very unreliable. We couldn't really take much data from that environment. Any movement of the mouse or anything could interrupt that, any amount of things, and it was difficult to grab points along the progress bar via the API. So instead, what we're doing is we're using Inventor Studio. So we open up a scene that I've created, and then it's a pre-created scene. All the Inventor Studio variables are already in there. We've got a pre-created camera in there. We've got pre-created textures. Everything's already set up. We open up the part, start Inventor Studio, start the render, and then we basically measure how fast your workstation computes this ray trace. All the variables are already in there in terms of how much of the scene we want to ray trace and for how long, all that kind of stuff. This scene is at a fixed resolution, so it doesn't matter how big your monitor is. It doesn't matter what. It's the same ray trace on regardless of what workstation you're on. It has to be. And there's various elements in here which make this quite an interesting ray trace, right? You've got a fixed camera with depth of field enabled. So I think the focal point is around the center cap of this wheel. And there's depth of field enabled, so you can see the background sort of blurs out as it goes across there. So it's got depth of field to contest with. We've got multiple lights in here. So I've got various lights sort of shining into the alloy wheels, scattering light around the scene. I've got directional lights shining against the exterior faces of the wheel. And I've also got 4K textures on the ground plane. So these are pretty sharp, high def 4K diffuse maps and bump maps on the ground plane. And yeah, it is challenging of a ray tracing scene as Inventor's going to get. And Inventor Studio is the only module, it's the only feature within Autodesk Inventor that will put your CPU at 100% across the duration of it. So this obviously goes towards your multi-threaded score, but it's the only true 100% multiple threaded operation within Autodesk Inventor. Once that's out, and by the way, one last point, this is super important. The ray tracing test does not count towards your InvMark score. Every other test that I'm talking about here has an impact and has an influence on the final graded InvMark score, but the ray tracing test doesn't. It goes towards your multi-threaded score. That's it. The reason for that is ray tracing is not an important feature within computer-aided design. I'm still testing it though, because it's a part of Inventor and some people do renders, but it's not important enough to influence a workstation's position on a computer-aided or an MCAD leaderboard for workstation performance. What I don't want to happen, this is my train of thought that I went through when I made this decision. I don't want somebody who's potentially got an Amazon instance. I can't remember what the Amazon instances are called, but they've went to Amazon Web Services, they've spun up an Amazon instance, they've assigned 256 CPU cores to an instance, and they run InvMark. I don't want that workstation will absolutely smash this ray tracing test, right? It'll finish it in probably 3 or 4 seconds, you would hope. I don't want that very, very fast ray tracing test to push that rubbish Amazon instance above a more genuinely capable CAD workstation on my leaderboard because of its one ability to perform a ray tracing test, right? My ray tracing test won't have that much weight towards the overall score, but I don't care. I don't want to risk it. I don't want that to actually happen. I don't want two workstations to be very close to each other, but one of them to gain the edge because it's better at rendering, right? It's just not important enough for that to be the case. So yeah, ray tracing doesn't go towards your InvMark score, but it does go towards your MT score, right? Then we move on into the final test. The final test is data translation. I'll say it's the final test. It is visibly. We've got other tests running in the background whilst this is all happening. So what we're doing here is we create a blank assembly and then we place a step file into the blank assembly. We extract the step file and convert it into a native Inventor model containing assemblies, sub-assemblies, and part files. It's a 77-part step file, and we measure how capable your system is of data translating that step file from a neutral file format into Inventor's native file format. This is a multi-threaded operation again. This uses and leverages multi-cores. Not 100%. Nothing is other than Inventor Studio. It's very loosely multi-threaded as well. You see very little scaling with the number of cores, but it is multi-threaded. So there's the step file appearing. It's a graphics, or it's an SLI graphics card assembly. Once that's extracted, you then have, right now, what you're looking at is a newly created Inventor assembly in RAM containing 77 parts. The next thing that we do is we save all 77 parts to disk, and that's the save to disk score, or the save to disk test, I suppose. So we're taking all 77 parts that we've recently just extracted from the step file. This is a brand new created assembly, and then we're saving them all to disk. We time how long your workstation takes to save all those files to disk, and then we use that as your save to disk score. And then that's the test done. It closes down, and then it presents you with your score. Right, once you've got your scores up, you've got a couple of options at this point. You can just look at them and go, oh, okay, I don't know what that means, and close Inventor down and get on with your day. Or you can upload your score to the leaderboard, which we want you to do, obviously, because we want as many scores on the board as possible so people can gauge what the scores mean. People have got points of reference. What I would strongly suggest you do, if you don't have a login already, is to click the leaderboard and then log in. Log in first. That kind of... It creates that account for you and ties it to your computer. So when you do upload your score, just make sure that it just makes sure everything's okay, right? I would suggest you do that. You don't have to, but I would. And then just click upload score. Click upload score, and you'll get a message to say that your score has been uploaded to the leaderboard. Right, one last point before I move on to the leaderboard and everything that's on there. When we're running our test, we have to make certain changes to Inventor. We have to make sure that the Inventor environment is exactly the same and identical, regardless of which PC it's on in the world and how long that Inventor's been running in the world, right? You know, it needs to be the exact same environment. So we import application options and then take them away afterwards. We try and put things back to the way it was after our test's finished. What I would strongly suggest you do is after the test's finished running, just close down Inventor and then reopen it back up, and you should be good to crack on. You shouldn't have to do that, but I would just recommend that you do, right? Just make sure all your add-ins reload. We have to unload all the add-ins from Inventor whilst our test's running. We've got no choice. We have to do that. But we've set it so that the add-ins should all reload correctly afterwards. Okay, the leaderboard itself, right? Once you've uploaded your score, you can pop on over to the leaderboard and see how your score compares with other people's. Okay, there's a lot to go over here. Right, along the top, we've got the leaderboard shortcut itself. That'll take you to this main page. You've got About InvMark, which I think I covered at the start. This is just, about me, links to my YouTube channel that you're watching right now, the download button, and some other bits and pieces. And then you've got About Kadak, and then you can check out those guys and see what else they offer. Right, the leaderboard itself. Right, I'm logged in. The leaderboard itself is kind of MVP's minimal viable product right now. We've got enough on here for it to be functional and to kind of satisfy where I wanted it to be on day one. But we've got some extra work that we want to do to this, depending on how successful this project is once it goes live. So there's all kinds of features that I know that I want to add to this, and I don't know if I'll talk about them as we go. I don't want to be like, oh, I wish I had this, I wish I had that. I'm not going to do that, but I'm happy with how this is. So I'll take you through what we've got. So the leaderboard itself is by default all Inventor versions and both desktops and laptops. So this is a combination of Inventor 2022 scores, Inventor 2021 scores, and desktops and laptops. Depending on who you are and what you're interested in, you can change what this leaderboard shows by selecting the filters up here at the top. If you're only interested in Inventor 2022, because that's what you're running today, you can change the filter over to 2022, and there's your scores for Inventor 2022. If you're only interested in laptops, for example, you can change the filter to say, just show me laptops, and then you've now got just laptops. Laptops are represented by a little laptop icon next to the score here. It's just a visible identifier that score was a laptop. I've also, the demands that I've made across the course of this project. I've asked to interrogate the certain properties during the upload to the leaderboard and to compile a name of the workstation, put it together and place that on the leaderboard so that people can see what kind of workstation had uploaded the scores. So, for example, this here, Dell Ink Precision 7550. This is a Dell 7550 mobile workstation laptop, right? This is the one I reviewed on my channel a couple of weeks ago. HP Z2 G4 Tower workstation. Dell XPS 13 9310 2-in-1. Pretty clear. I'm loving how well that's worked out. Lenovo ThinkPad P50, and then some of them, some blank characters and some very old laptops need a bit of work done, but it's not the end of the world. Right. We've also got custom desktop PC. This is me saying, right, look, if you've built your own PC, if we identify that your system is a desktop and it's not from like Dell or Lenovo or HP, it's not an off-the-shelf system that we recognize. It's got an Asus motherboard in it, and it's just, it's a combination of parts, and it's a custom PC. Well, we're just going to put that there, right? Custom desktop PC. And that's what this is. It's all come out correct. This here is my custom desktop. It's an i9 10900K. I built it myself, so it shows as a custom desktop PC. We've also broken the scores down into categories by color and by name. I don't know how well this is going to work out, right? But in my mind, I wanted to kind of gamify this and give each score its own little tag. I don't know how this is going to work out, but the top score on the leaderboard is going to be classed as the hero score. I didn't want to be cheesy and call it the champion, right? Or the gold, right? I hate metal names. So I've called it the hero score. There's only one hero score. There'll be one for Inventor 2021, and then there's one for Inventor 2022. Everything else is graded by colors, and it's the same color scheme that you would tend to find in games, right? You've got orange is sort of the best, then you've got purple, then you've got blue, then you've got green, gray, and then red, I suppose. Well, red, I haven't made up the red one. So between hero and epic, there's a tag called elite, which I don't think we've got one here, no. But scores that are uploaded to the leaderboard that are very, very close, very, very close to the number one spot will be tagged as elite. Then scores which fall within a certain extra range of the number one slot will be listed as epic, right? They're still very good scores. And I've worked out all of these percentages very carefully. I've taken workstations that I've got here that I know are extremely capable. I've measured them, graded them, looked at where they land on my leaderboard, and I've scored them and named them accordingly. And I've done all of this, by the way, without any vendor support. Dell, HP, Lenovo, none of those guys were interested in helping either myself or Karak throughout the development of this. So we've done everything with regards to the work here and putting all this together without any vendor support. So all of the systems that I've got here are my own, systems that I've bought myself. And I've used all of those to kind of build and get a good idea of what kind of scores things should sort of fall into. But after epic, we've got blue. Blue's kind of, it's good, right? It's not the best, but it's good. It's capable. It's adept. That's the name of it. Then we've got green, which is common, which is average. It's not great. It's not great. It's just middle of the road. It's mediocre. And that's where these have come out really well. If I'm honest, I'm so pleased with how these have actually come out, because looking at the workstations that we've got here, the hero score is an i9 10900K. It should be at the top. Then we've got epics, which are mobile workstations. Then we've got this one here, which is a Xeon 2278G. So this is sort of a that's the equivalent of the i9 9900K, I think. Xeon. And then we've got this here, which is a Ryzen 3600, which falling around blue, adept. Dell XPS 13. I mean, look how good that is, right? The Ryzen 3600 and the Dell XPS 13 2-in-1 sort of almost locking horns. But then we've got HP Z2 Tower Workstation. So this is a Coffee Lake generation Xeon. And then in the greens, we're looking at kind of Ryzen 7 1700X, right? First generation Ryzen. I would expect that to be kind of mediocre, middle of the road, and it is. So that's good. My scores have worked out quite well. And then this here, which is an old Lenovo with a 6th generation i7. And then very poor is an old Inspiron 7720 with a 3rd gen. So the scores and the ranges have worked out absolutely perfectly. Okay, those are the main scores. However, I've taken this a step further, because when you expand any of these lines, if you click the little down arrow next to these lines, you're given a set of sub-scores. So all of the single core scores, multi-core scores, are given their own grade, and they're based on the highest score on the leaderboard. So this mobile workstation 7550 scored 11,851 points on the single core grade. The highest is 13,251. So we grade this score based on how it performed and how it compared against the highest single core score on the leaderboard, just like we do with the main scores. And we do that for every single score within the InvMark suite. So we take a modeling score, a drawing score, an assembly score. You can then go into the complete report, and you can see the assemblies. The assemblies score, there isn't an assemblies test, right? But this score is a combination of all of the assembly tests that we did. We create a combined assembly score based on the multiple assembly tests. So yes, there's an individual assembly pattern score, there's an individual assembly build score, but then we create an assemblies score based on how well all the other assembly-based tasks did. Dynamic Sim, FEA, right? And you can see, oh, okay, ray tracing wasn't so good for this test. Why was that average? Why was that average? Okay, it's a laptop. But yeah, okay, laptops will overheat when everything's at 100%. It'll probably thermal throttle. Yeah, I would expect that to actually happen. So that has happened. Good. So then you can look at all of these. These are all given their own scores. You can see there's the elite. So for the assembly pattern, this laptop actually scored elite for assembly pattern. And it's interesting. It's interesting to see how individual systems handled and landed on specific scores. Okay, on the right-hand side, you've got the system stats. The system stats, they are kind of complete, but there's still some bits and pieces I want to add in here, but they're kind of complete. So at the top, we've got the name of the workstation, which we've already seen. It's on the main part of the leaderboard. We've got the computer name. This is mostly, it's not sensitive information, your computer name. But this is mostly for people who, like myself, who are uploading multiple workstations to the leaderboard. You need to be able to see what unit is which unit, right? You get lost on the amount of computers you've got. But if you expand some of these system properties have a drop-down arrow where you can expand it, and you'll see the operating system. And then the manufacturer here will show, for example, if it's a custom desktop PC and you show the manufacturer, it will tell you what like motherboard it was. If it's a Asus motherboard or an MSI motherboard, like what manufacturer is at the heart of it, right? What's the vendor of the motherboard? Okay. The rest of the system properties, we've got graphics card, right? So the NVIDIA Quadro RTX 3000, if you expand that, you'll see the quantity of the video RAM. You'll see the graphics driver version, very useful for troubleshooting, right? Detected display resolution and monitor resolution, right? It's saying unknown at the moment. You will see quite a few results that will say unknown. There'll be a lot of instances where when we pull and grab the system properties, we just can't read them for various reasons. And one of them is remote desktop. If you're running the test over a remote desktop, the resolution isn't recorded in the same way as it would be if you were sat physically at a monitor. And I don't care enough to fix that, right? If you're running a remote desktop, I don't care, right? It's not the end of the world not reporting the resolution correctly in every case. But in the instances that it does report correctly, what you'll see is the available resolutions listed here. So this is my main desktop. I've got a 2560 by 1440 TV running at 120 hertz and a 5120 by 1440 massive widescreen display running at 60 hertz, which is that Dell U4919DW, huge Dell UltraSharp widescreen monitor, which is the monitor model there. Currently, we don't list both monitor models. That's one of the things on the to-do list. It's just listing one. Right. Then we've got storage drives. The main storage drive, your boot drive, will be listed first. And then all the other drives here are all... We don't care really about the storage drives. They're not an influencing factor in the test, but we just list all the drives there, and your main boot drive is at the top. But I'm not interested in how fast they are and how big they are, right? It's not meaningful information. The RAM, okay, 32 gigs, DDR4, 3600 megahertz, non-ECC. I was so happy that we managed to compile that information and get it like that and structured like that. So where that bit of text is a combination of multiple different system properties pulled from different areas. So we're reading the RAM frequency, and then we're also grabbing whether or not your RAM is ECC or non-ECC. So for example, if I go to one of the HP workstations, for example, this one here, and then look at the full system report, you'll see here it says 32 gigs of DDR4, 2667 ECC RAM. So it's correctly identifying that RAM is ECC. If you expand that, it'll show you the memory brand. So it's Hynix, the memory model. And then what we also do is my developer hates me, is we pull all the memory banks. If there's a memory bank populated, we will put that and list that here, as well as every stat available for that bank. So RAM channel 1 has a 16 gig stick, and that's the type of RAM that's in that bank. And then the last system property is the Inventor version. This one's super important because Autodesk can change the performance of Inventor between point versions, right? They can release 2021.2, which can change the performance. So we need to identify what version of Inventor the test was run on. Below that, we've got the history. The history is only visible to you. Nobody else can see this history. So if I take my main desktop workstation and I upload a score of 49,496 and it hits the top of the leaderboard, get in. Yes, made it, right? But maybe I caught it on a good day, right? After that, I install antivirus. I've got all kinds of things running in the background, right? I've got emails going. I've got all kinds of stuff going on, and I can't hit that score again. I'm running the test. I'm uploading. I'm trying to beat it, but every time I upload a score, it's lower and it's lower and it's lower. Me as the creator of this program, I don't want hundreds and hundreds of lower scores from the same workstations spamming my leaderboard. So what I do is you can upload as many scores as you want from the same system. Only the highest score will appear on the leaderboard, and only you will be able to see your previous submitted lower scores, and they'll all be listed in the history. So for example, my score of 45,496 was uploaded on the 11th of April. That's my highest score. But then you can see on actually that's an Inventor 2021 score there. But yeah, on the 8th of April, I managed to hit 44,197. Nobody else can see that score other than me, but I can click it and I'll get a full report of what was different about that test, right? Why was it lower, right? There's my highest one. There's my lowest one. And you can look and compare, right? There's no side-by-side comparison or anything like that, but you can just flick between them and see, right, okay, well, 45,496, I got 2263 on the graphics. On this one, I only got 2184. Okay, 1410. This one got 1355. Why? You can look into it in an experiment, right? So that's your history. Only you can see it, and you can upload as many times as you want without fear of people seeing, much slower scores than what you actually managed to achieve as the best score. At the top of the leaderboard, right, you've got my benchmarks. Most people are only going to have one line in here. This is all of the systems that you've uploaded, the best score that you've had just listed in here. It's just your benchmarks, right? So for me, every one of these PCs is mine. So they're all listed in here. I can just jump to like my Ryzen VR system. I can just give that a click and it'll just take me to that system. Yeah, it's just a list of all the scores you've uploaded. And then your highest rank, that's just a shortcut. So if we do end up with hundreds of entries on this leaderboard and you're entry number 80, for example, you can just click that and it'll just jump you to the leaderboard position that you are. One more thing that I forgot to mention, it's probably quite obvious, but when you look at all the scores, you'll see that there's like a second number next to them. This is a comparison against the highest score on the leaderboard. So for example, if I'm uploading from this Lenovo laptop, for example, so I get a score of 7685 and I'm like, okay, well, is that good or bad? I don't know. This number here is the highest score ever for a single core upload. That number there is the highest score for a multi-core upload. So it's just comparing your grade with what the highest so far was. And it's been designed to only compare against the current, or that version of Inventor. So if this scorecard was for Inventor 2022, we are only comparing against Inventor 2022. So if you upload for Inventor 2021, for example, let's go to the Inventor 2021 leaderboard, and we look at something quite far down on the leaderboard here. So this upload, 7054, is compared against the highest score for Inventor 2021, right? So we're keeping it all with it. Everything is localized within Inventor versions, because between Inventor 2021 and Inventor 2022, they're essentially, for all intents and purposes, completely different products. They can't be compared on the same leaderboard. So that's why we've got two different filters here. One last thing, just to make you aware of, you do have the ability to change, and I would advise that you do, just to make the leaderboard, your own. We're going to work on this and build on this again, depending on popularity. But if you click your name at the top right, you can go to my account and you can change your name. By default, I think it defaults to your system name. I don't remember, but you can type in your name there, give yourself a nickname, which appears on the leaderboard. And also you can put in your country code here. It's not a drop down yet or anything like that. What you have to do, if you just look at this little hyperlink, where am I from? Well, I'm from Barbados, right? Okay, well, I need to type in BB, right? Or I'm from Costa Rica, so I need to type in CR. When you type that in, click save. It'll put a little your country's flag next to your little avatar. In the future, we're going to have avatar icons here, right, with little pictures. At the moment, right, that's not a priority for going live with this. So that's my account. That's the website. And there's one more thing I want to show you before we wrap this up, and that was the performance logging, which I wanted to leave to the end because it is so good. If you want to see how your system behaved over the duration of your InvMark test, whether it be an individual test or the full InvMark test from start to finish, we log all the sensor data from your PC and we log it to a local CSV file on your computer. If you want to view that data, go to C, temp, and in there you'll see a CSV file called Open Hardware Monitor Log.csv with a date on. This is only going to be the previous test run. If you run InvMark again, it'll overwrite that CSV file with the last test. So you need to make sure you grab that CSV file from the test you want to actually monitor, because it'll get lost when you run another test. What I would suggest you do is just grab that and move it to your desktop. You don't have to, but just get it out of the way so you don't lose it. And then go to C, Program Files x86, InvMark. In here, you'll find a file called Hardware Monitor Sensor Template. Again, grab that, move it to your desktop, just copy it over there so you can just shut the File Explorer window down. Okay, once these are over on your desktop, open them both. Just double click both of the files and they will both open in Excel. You can ignore this possible data loss message at the top. There is no data loss in there. Right, expand both, maximize both, and then go over to the sensor log. This is all of the sensor logging that we do, right? There's no personal information in here. This is just your CPU load. It's your CPU temperatures. It's just that, and it's just numbers. That's all it is. It's numbers, temperatures, frequencies. So to make sense of this data, what you want to do is delete the word time from A2, select the entire spreadsheet, right-click, and copy. What you then want to do is hop on over to the monitor template, select cell A1, right-click, and then paste values. Then go down to the chart sheet at the bottom, and you'll see a pre-created graph that I've put in here. It is not pretty. I'm not an Excel spreadsheet expert. I can't do charts, right? It's the best I could do for the time that I had. Once it's there, right-click in the white space in the middle, select data, and then select the little top icon here again. I just select that, click OK, and then that fills this graph with your sensor data and make sure that all your data that you've put in is now populating this chart, because everybody's PC has a different number of sensors, right? Every PC is different. Some PCs have 12 sensors, some have 3 dozen sensors, right? It's different per PC. Right, once that's done, if you want to, you can change, you can grab the chart and move it around if you want to, just to kind of get it in view. It's difficult on a remote desktop session looking through this, but you can grab it around like this. There we go. Okay, at the bottom, you've got a legend. The legend is each sensor on your PC. Granted, it's not the most user-friendly, right? It's difficult to understand what each of these are, but this is only really for people who kind of, if you can understand what the data means, I partly expect those people to know what each of these legend items are. If you don't understand what the sensors mean, then I wouldn't really expect you to be interested in what this is and doing this, right? It's one of those things. So, for example, if you want to look at your CPU temperature over the duration of InvMark, if you've got concerns about thermal throttling over the duration of InvMark, or just generally with your PC, you can look at the legend to see which of these items correspond to your CPU temperature. So that would be Intel CPU /0/temperature. And you can see we've got core 3, core 4, and we've got a temperature sensor per core as well as a package sensor. You've got the option of graphing each core individually or just the package. It's up to you. But what you do is give the white area a click on the outside. Okay, I think it's gone off. It's gone off. Yeah, it is. There it is. You need to see that funnel thing there. You need to make sure you can see that. If you maximize this too far off, that goes off the screen. So click the funnel, untick select all. And again, this is not ideal, right? Because it's the legend items are so big, the words get chopped off, and you can't make this bigger, unfortunately. But there you can see is Intel CPU 0 temperature. So if you want to look at the graph for all the core temperatures, you can just tick all the core temperatures. If you want to look at just the package, well, it was the last one, wasn't it? So it was that one there. Give that a tick, click apply, and there you go, mate. That's your Intel CPU temperature package over the entire duration of InvMark. And now you can see it's graphed all along. So at the peak, well, it's peaking there, isn't it? So we peaked at 93 degrees. And I suspect that was the ray tracing test. I suspect that was the ray tracing test. If you want to be sure, what you can do is you can go to C, temp, logs, open up the benchmark log, and then you can scroll down. Oh, damn it, my logs. I've lost my log. All right, I've lost the log that actually corresponds to this. But you can scroll down and then look at the log and then look at the area where it says the ray tracing test began. Look at the time code of where the ray tracing test started. And then if that corresponds to this time code here, so this is midnight, so of 0016, look at, if it corresponds to that, then you know that's the ray tracing test. In the future, and this was my intention all along, is we're going to convert this automatically to the website. And then we're going to overlay each of the tests onto the graph as like a colored region. So we're going to take our log and then color this area in to say this is the ray tracing test. This is the modeling test. This is the FEA test. This is the drawing test, for example. But at the moment, you'll have to do that manually. So that's your CPU package temperature, and you can just carry on doing this. It's so, for me, being a nerd, this is absolutely fascinating to look at. Like, for example, CPU frequencies, for example. So you can look at the clocks. So we can look at the clock frequency of all of the cores. So CPU clock, 2, 3, 4, 5, 6, 7, 8 cores. Click apply. And there's my core frequencies across the entire duration. So if you put an overclock on your CPU and you're not quite sure that you're actually achieving that overclock, or you thought you were, but you want to check, you can actually now see whether or not you're actually achieving that overclock. So you can now see, just hover over, series value 4.9 gigahertz, 4.9 gigahertz. So you can see that this CPU never went over 4.9 gigahertz at any point over this test, right? That's pretty much the max. And then what I can do, if I wanted to, is just look at the factory spec of the CPU. Should it have gone higher than 4.9 gigahertz? Is that, should it have gone past 4.9? Should I be getting 5 point something? But you can see here, there's some interesting points, right? What's happening here is dipping right the way down to 3.8 gigahertz. What's happening here? This is thermal throttling. This is the ray tracing test. This is the CPU putting all of its cores at 100%. Overheating, probably not the right word, but getting very hot. The frequency has to drop to keep the temperatures in check. When all the cores are at 100%, the CPU gets too hot. So it has to lower the frequencies during that test. I find this absolutely fascinating to watch. You're witnessing the stuff that you've always wondered. No other benchmark test has this, by the way. No other benchmark test on the planet that I'm aware of actively monitors the system sensors whilst a benchmark is actually happening. People can do it themselves, obviously manually, but this is now going to automate it. And then, and you've got all of these sensors, right? That's just two of many, right? You've got like your RAM. You can look at RAM load, how much RAM is being used over the duration of your test. So at one point, we were using nearly 18 gigs of RAM around this point here. So my test is intentionally designed to stress systems that are around 16 gigs of RAM. That's not accidental. That's an intentional design intent. If you've got an 8 gig of RAM system, you're going to struggle with InvMark. It'll run, but you'll struggle. And this hardware log will show you at max RAM utilization over the duration of the entire test. So yeah, that's the hardware graph. If anybody out there is an Excel expert and they're able to make this automated better than this, and just make this better, and want to do that with the kindness of their own heart, by all means, let me know. But yeah, this is the best I can come up with for just manually converting this to a usable chart. And then you've got your GPU stuff as well, like GPU load. This one here, I think. Yeah, GPU core load. So here you can see, like when the modeling test starts, the GPU kind of spikes to 90% for a very, very, very short amount of time. And then this here, I think, is the graphics test. Remember back to how much work was actually happening throughout the graphics test. We were orbiting a 1,000 part assembly multiple times, and the graphics card at no point ever went beyond 80%. Right? Look at it. It's peaking at 74%. I've just answered a question on the Autodesk forum from someone saying, would a 3090 be better than a 3070 for Autodesk Inventor? Come on, look at this. It's just not using your graphics card. I've been banging this drum for so long, and now you can now witness it. You can now prove it tangibly with metrics that you cannot argue with. When Inventor is running extensive graphics test, it's not using your graphics card. It's right there, right? You can't argue with that. I don't think anyone was arguing with me before, but now you can see it happening, right? It's actually there. And then you can also see VRAM. Like one of these legends is VRAM utilization. But VRAM is very situational, right? It depends what models you've got open and what else you're doing, what resolution screen you've got, how many monitors you've got, right? But we do have how much VRAM is being consumed across the course of the test. That is another stat. I don't know which one it is. What you can do is you can go back to the template and you can look at the legends, and you can check what the legends are, and then look at the numbers, and you can look at that before you go over to the chart and then look at the funnel. Right? You can do that as well, or you can just turn all the ticky boxes on and look at them there. But yeah, that's I'm so pumped for this. Currently, this is all local. This data is only stored on your local PC. But in the future, we do plan on uploading this CSV data to the website and converting that automatically into a chart on the website for every uploaded score. But like I said, you can clearly see in here there is no personally identifiable information. There's nothing to be alarmed about or concerned about. But we'll be putting that in the privacy policy anyway, just to make sure that it's we're okay with that, Right, I've covered as much as I think I need to cover. There's a lot of other things about InvMark that we've worked on. Anti-cheat mechanisms. There's, you can reuse it on multiple monitors. There's all kinds of things that I could talk about, but I just want to get it out there. I want people to start using it. I want feedback from people as well. I'd really appreciate some good feedback from people. At this point in time, I'm not sure what the best channel of feedback is. Keep an eye out on this page here, the About InvMark page. We're maybe putting an email address of some kind on here for how we want people to feedback problems. I may be running a Discord channel separately, just offline, nothing to do with Karak, right? Just for me, just for people who want to talk to me about this. I've already got one, but any formal requests for bug fixes and, that kind of stuff should go this direction. But yeah, I'm just kind of playing around with ideas there. That's InvMark for Autodesk Inventor. I'm so relieved at this point. It's been a long road to get here. It's been a far bigger job than anybody who's worked on this could have possibly imagined. The involved tasks to get the benchmark test ready, who knew? Who knew? Certainly not me, certainly not Karak. But, it is what it is. We got there, and there'll be some issues, no doubt, when it goes live. We've tested it on as many systems as we can. Like I said before, we've had no vendor support from any system, tier ones or Dell, HP, Lenovo, those guys. There may be some instances of uploads which might fail because of situations that we couldn't predict, because I could only use the hardware that I had available, right? I've got a fairly eclectic variety here of systems, far more than most people would have, but I can only use what I've got and test with what I've got. Yeah, we ran a closed beta program as well, but because of the nature of the development, we couldn't always keep going with the latest versions. It was just tricky. Anyway, right, well, I'm going to knock that on the head there. Thank you very much for watching this. Like I said, it's been a long, waffling, unhinged video. I want as many feature requests as well as you possibly can do. I want to hear some good ideas for how we can improve this and make this better, make this intelligent, make it smart, make it interesting and fun. I want this to be a fun benchmark. It's so far, I find, the scores and comparing the scorecards fun. I find the hardware sensors fun and interesting and engaging. I want to hear more ideas like that. If anyone's got those kind of ideas, let me know. Thank you very much for watching. I'm Neil Cross. That's InvMark for Autodesk Inventor for you for free for your delectation and delight. And I'll see you all in the next one. Thank you very much. Toodles.